Okay, so the Regents question 4.2. I just want to go back, I guess, and do a quick review before we hit those, what we did yesterday. So we're now on to similarity transformations, not congruence transformations, right? Similarity. So they're not going to be exactly the same size, but they'll be exactly the same what? Length. That's it, just the length, of course. Shape, right? They could be the same size, couldn't they? Certain dilation. What? A 1, right? So that allows some other transformations to fall into the similarity transformation category. So you remember that also, rotations, reflections, translations are also similarity transformations, right? Would all the corresponding side lengths be proportional for all of those? What would be the ratio if we did a translation of the corresponding side lengths? What to what? What? You see noodle?
New over old.
Right, give me numbers though. What to what? If it's a translation.
2 over 1.
So we do a translation, the new one's twice as big?
Noodle over.
What to what? 1 to 1, right? So 1 to 1 equals 1 to 1. Is that a proportion? Yeah, that's a proportion. It's 2 equal ratios, right? So technically they are similarity transformations. Whoops, let me do that. Okay, and so we have a new symbol here for similar, right? Remember this? I think it's called a tilde if you see it on the keyboard in your computer or something. So top left above the 1 key, I don't remember. Okay. And then they went through and did a bunch of things. So this is important here. When we do a dilation or two figures are similar, do the corresponding angle measures get different at all?
No.
No, they are all going to be congruent. Okay? All right? Now the corresponding side lengths, if they're similar, not necessarily congruent, but what?
Proportional.
Proportional means that all the corresponding pairs will be in the same what? What's a proportion?
Yes.
Ratios, right? They'll all be in the same ratio. That's what proportion is, okay? So again, we have to think about naming them correctly, right? Listing our triangles or whatnot in corresponding order, which I believe there were a couple on your homework like that, right? And then they did some similarity transformations, blah, 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 right? What else did we have? Yeah, okay. So we covered all that. So let's go ahead and take a look at then this first Regents question. Read that over. Make sure you're identifying perhaps any key words in there. Like what in this case? Not. Okay. So which one there, kids? 3. It's a dilation in 3, isn't it?
Yeah.
What's the scale factor in 3? What? 1. So that'll make it not congruent?
I'm thinking 2. That's 4.
It says not congruent. You know that reflections make them congruent, right?
I'm thinking they would fold them like, different way though.
It doesn't matter because when you get done, they'll both be congruent. They're rigid motions, right? So it's going to be choice what?
3.
Wait, keep saying 3. Okay. On to the next one. So we've got a reflection and a dilation, right? Are they both similarity transformations? Yeah, they are. And it looks like all the choices are referring to what parts? Angles. Whether it's congruence or similarity, what do you know about all the corresponding angle measures? They stay the same, right? The trick is corresponding, right? So angle measures are going to be preserved, right? What do you guys think? 2? Measure of angle ABC. They could have just said B. Congruent to ADE. Okay. Well, we need to know. So why isn't it choice 1?
Two different angles.
Well, these are 2 different angles as well. What does he mean to say? So what's this angle and that angle? Why would they not necessarily be congruent after any of these transformations? They're not corresponding, right? They have to be corresponding angles. So that does leave us with choice 2. All right, moving along. Now we're on the next page. After you read this, I want somebody to tell me which triangle is the pre-image and which one is the image. Pre-image, how do you know that? We'll map triangle ABC, the smaller one, onto triangle DEF. Okay? So that's how you know. There's no primes or anything, right? Okay. So starting with triangle ABC. Which one do we think? I heard 3. I heard 4. 3. Well, let's take a look at it here. So dilation of ABC, number 1, dilation of ABC, scale factor of 2, centered at, why is it not choice 1?
If you rotate the line,
Right. It looks like there's a rotation involved here, right? Why not choice 2?
yes.
Yeah, 1/2 is a reduction, right? This is clearly an enlargement. So we said choice 3. Well, how do you know? If they didn't say, if they had a bunch of different scale factors in there, how could you tell? How could you tell?
Starting the units. Oh, then
Yeah, okay. Or either, not even, you don't have to do both of them, right? Any corresponding run or any corresponding linear measurements, right? It's centered where? This says at the origin, right? So let's see here. What does A correspond with? D. Well, let's get, right, K is new over old, right? So what was the old difference from the center to A? 2. And then from this new, right, to D is how far? 4. So new, yeah. I'm going to write a K again. 4 over 2 equals 2, right? So if they didn't just give you, I mean, obviously a choice between 2 and 1/2, you just got to know which one you started with, right? But if it was a little different, you want to know how to do that. You see how I pick any corresponding linear measurement? It could be the run. I could have picked the rise, or I could have, you know, if there were some nice horizontal sides to this, I could have gone with those, okay? All right, let's go down to number 4. Well, this one should be pretty straightforward. Keyword in there? Not. So what's our answer?
4.
It's got it. It's the only one that, right? All the other ones are congruence. They're also similarity, right? But scale factor 1, so it won't change the size. Number 5. Now, so what do we think here about number 5? What happened here? Got to be. They're different sizes, right?
And the orientation stayed the same too.
It did. So you're not going to have a reflection. It's a good catch on that. So it's a dilation and a rotation. Number 6. What are we thinking? Which is the correct sequence here?
4.
Thinking 4? Okay, counterclockwise rotation, 90 degrees. Yeah, it looks like it probably did that, right? Followed by dilation of scale factor of 2. All right, so again, how would you know the scale factor was 2 if they asked us a little bit differently?
Just multiply the numbers by 2 maybe?
Yeah, in some sense you could do that. Gotcha. So give me a new measurement and an old measurement to compare here. 8 and what? Okay, that's one of them. Sure, 8 divided by 4, which gives us 2. Okay? We're doing the Regis questions for 2. And I think this is the last one. Get it over.
We got
Yeah, this is one of those you got to think about these choices here, right? So now there's also a key word in here. So you think about it. Anybody want to hazard a guess to what I'm getting at? Mhm.
what's it sequence? Always.
Always. Right? Always. So some of these things could be true sometimes under certain situations, right? They want always. And with these, I like to, before I even look at my 4 down here, I like to just go through these one at a time and either cross them out or circle them, and then I just find it matches up. What do you think? So we have a dilation followed by a translation. What always has to be true here? Okay, so let's look at these up here. So the answer is 3. So let's look at this first choice, Roman numeral 1. Will they be congruent? Always. They could be, right? That's why they put always in there. If the dilation is scale factor 1, right? So no. What's number 2 say? Triangles ABC will be what?
Similar.
What is it? Similar, right? So that's always going to be true. What about this? AB parallel to A prime B prime. Well, if we have a dilation and the trans, it didn't get rotated or anything, right? So don't translations keep corresponding sides parallel? And don't dilations also keep corresponding sides parallel? So if you do both of those, right, that's got to be true all the time. Both of those keep corresponding side lengths parallel. And this one here, this is from A to A prime equals a measure of the distance from B to B prime. Not necessarily, if it was just a translation, right? So in other words, the path that A took to get to its new position for the translation, right, is not necessarily going to be the same as the path that B takes to B prime. Why? Because under a translation, that would be true, right? But what changes this here? The dilation changes that, doesn't it, right? Okay? So those points move first to different locations and then travel, all right? So we'll admit that, and it's choice 3. Oh, there's one more after that. Sorry, I thought that was, okay? Let's read this last one and think about how to answer that. Well, let's talk about how to answer this. Any thoughts?
I think no.
Okay. Are they congruent? He says no. We agree with that, right? So why?
Dilation can only be congruent if it's different at 1.
A scale factor of 1, right? So if it's a dilation of 1/2, what is not preserved?
Side length.
Side lengths, right? Okay, so they're not congruent. So the answer will be no. Let's word it. And, you know, this is one you'll word in whatever way you're comfortable with, as long as you have certain elements in there, right? No. A dilation of 1/2 what?
It's not congruent.
Say it again? Yeah. Does not preserve side lengths. Okay. So we can say they're not congruent. So triangle, how do they state it? Yeah. A, B, C, not congruent to triangle A prime B prime C prime. Let's add a little something here. What will the triangles be? There we go. Let's just tack that on there. They are similar, but not congruent. Okay?